All right, so just passed our veneer inspection. We've got our standard system here is to use a 7/16 OSB zip system from Huber, which is our structural sheathing with an impregnated air and water barrier on it. You'll see the brown or orange version of that. We use that on the roof. It's 5/8, slightly thicker. Holds up, but the whole system is proprietary. We really like it. We've got all different kinds of tapes and sealants that come with it to help keep that monolithic, continuous air and water barrier. So we've got our zip stretch tape here that's on top of a 2 to 3 degree beveled sill. So any wind-driven rain that were to get in there is going to be able to migrate out. Taking the nails out of here just to show you that this bottom flange, we've got a little gap here. So if I was to tape this bottom flange, and I would just be relying on the hope that no water got in. But if it did get in, it would have no way to get out. So we go back and nail this. We're gonna shim this out a little bit just so that any water that does get in there has a way to come down that slope sill and out. We've also got the standard flashing tape that goes over the seams so you can see kind of the order of business. You do the sides and then the top. We've also used their liquid flash product as a secondary seal where our sheathing meets our masonry foundation. If you remember from earlier videos, we have a detail we like to use with a sill sealer and 2 beads of caulk, one on either side of the sill sealer, sandwiched down in between with our sill plate. So this is really just a backup defense against any, drafts, water, ants, anything like that. So part of our inspection as we go around before we start siding, obviously we need to get these nails back in these bottom flanges. There's a couple spots here where we might have an overdriven nail or two, and we can always just hit that with a little bit of liquid flash. And then on top of this is going to be the zip system rain screen, which is going to allow for all of our cladding, which is a combination of hardy and boral products, to be able to have air circulation behind them. It's going to help with the paint adhering, and any water that gets in can drain, has a drainage plane to come down and out, and then air is going to be able to go up and around and keep that siding nice and dry, which is what we're looking for. All right, let's check out the inside. All right, so we've got our framing inspection today, and this is kind of the expectation of what our projects look like on the inside. Whether we've got a meeting with the client, whether we've got an inspection, meeting with a subcontractor. I don't like to see piles of dust and sawdust and nails and everything. This is clean. So, on a typical end of the day, our expectation is that the job site's swept up. For a day like framing inspection, we've actually gone through with the shop vac into every little stud bay, and this thing is spick and span. And the reason for that is, as you come over here, I've got to draft stop any penetration, whether it's a wire or a plumbing pipe, before our insulation goes in. That's part of our framing inspection. If I got piles of sawdust and everything, I might miss one of those. And it's just, kind of our on brand for us of how we like to do business. We like things neat, orderly, on time, on budget, and it just starts with keeping a clean job site. We're going to do our own walkthrough first and try to catch anything that might be missing, but we've got to have all of our trades inspected. So for this one, we had natural gas, we had electrical, we had mechanical for new HVAC, no plumbing. So all those pass with flying colors, and then we're going to come through, we're going to clean up, we're going to put our draft stopping in, which is all that little orange spray foam in any of our penetrations. We're going to double check that our header sizes are what was spec'd for on the plans. There are no special hangers or anything called for in this space, but as we go upstairs, you'll see that there are some Simpson Strong Tie products that were called for. So we're double checking that all of those are in and nailed, and that we're essentially ready for insulation. So this is the last time that we have a chance to look at these open stud cavities. So if there is a realization that we need to move an outlet or move an HVAC register, this is the time to do it. All right, come on upstairs. We'll take you into the second floor here. So the space we're in now was originally unfinished, I believe, and then maybe in the mid-2000s, the last owner turned this into a primary suite. And the bathroom was, really functional for them. We were going to do a 2-story addition on the back, and we were going to make the back room an office. We thought a little bit more about it, and talking with the client, it made more sense actually to kind of walk through the public space of the office. And we've created kind of a sitting room here, and then moved to the private space of the bedroom in the back. So we're going to have French doors here that'll be glass leading into, behind that zip wall, are a bunch of existing windows, so the client will have a really nice home office there. We're kind of in this sitting room, and we changed the window configuration to line up with with that box window that's on the first floor. And then as we come through this cased opening, we have the existing bathroom, existing closet, which is going to tie into our new space here. And now we've got this killer primary suite. We've got, with the Gambrel rafters coming down, it's got this really nice, intimate, cozy feel here. Got a ton of windows, lots of natural light. We've got a great bed wall, which is important when you're designing that bedroom. It's not just about the square footage, but really thinking about where are the pieces of furniture going to go, how's the layout going to work. So you can picture a big king-size bed here, and by putting that second story on that addition, we've actually kind of screened some of the views of the neighbor's house and yard too. So it's a fairly tightly packed neighborhood here, but we were able to create a space that has very little, that has very private views. All right, so we're back up on the second floor, and I wanted to just talk some of the framing details up here, because the Gambrel is actually a fairly tricky one to do. There's a lot of industry going up and to create this. So you can see that we've got all of our Tico hangers here as these rafters from the shed dormer come down. This is a good cross section here of what that normal Gambrel would look like, and what we have on the other side, where we've got that upper mansard rafter and then that second mansard rafter coming down, which is going to bear on that exterior wall. And then our wall, if we don't want that sloped condition all the way to the end, is going to be built inboard. So if you follow me over here, you can see what I'm talking about, where this is the outside, and the slope, the really steep pitch slope that my 5/8 zip is following. And then this is my vertical wall, so that we don't have that awkward little, knee wall space to deal with. Engineer called for some plates here just to help tie this together. And then we've got our Simpson products on the bottom too, locking everything in. The real monster in this room is the ridge beam. So on the other side of the house, on the existing mansard that we extended, we had a ridge board condition, and the rafters themselves were taking all the load. In this scenario, it was designed with a ridge beam. I don't know if you can get a shot of that up there, but we have a triple 16-inch LVL, and all of our rafters are hung on that. I'm certainly not an engineer, and rely on working with really good ones and architects to get all these details right. But essentially, anytime you've got that horizontal load, we need to bring that down to ground, and it's got to travel all the way to the footing. So if I've got that ridge beam that can span this almost 16, 20-foot long room here, I've got a post, right? So I've got that PSL up there that's going to come down to this LVL header, and then the LVL header has got double jacks in the middle and on either side. And then if we went down to the first floor below it, we would be picking up that load, spanning it across with another header, the French door, and then extending it vertically down to the masonry wall, which is bearing on the footing. So everything is always going to travel to ground. You can see another example of that here, where the drawings, this is where the wall separating the bedroom and the closet wanted to be for symmetry. But if you come on this side, the actual masonry wall below is over by about 15 inches. And so I've got my 4 jacks that the plans called for that are bearing, that ridge beam is bearing on, had to be moved back so that they could bear on that masonry wall. So again, this is where aesthetically that wall needed to be. This is where structurally this post needed to be. Both need to happen, and then the solution is just to box this out. This is part of a closet area anyway, so it'll get hidden in that. But really important to get those details right so that this thing stands for another 100 years.